Hi again. This is an example problem from chapter number 6 in our Russell and Taylor textbook. And basically what we have are two processes. The current process uses metal parts, and the proposed process uses plastic parts. And we want to compare these two processes with each other. With the metal parts, we've got fixed cost, FC, fixed cost of $50,000 versus a fixed cost of $170,000 under the plastic process. Regarding variable costs, we've got $5 per unit variable cost with the metal parts, and the plastic parts is cheaper, $2 per unit. The sales price in both cases is the same. Let's assume it's $10. First thing we can do is calculate the break-even point for each of the two processes. Now the break-even point is where the total revenue is equal to the total cost. So first with the metal parts, our total revenue is 10 times the number of units X that we sell, which is equal to the $50,000 fixed cost plus the $5 variable cost per unit, and then we simply solve for X, and we get the break-even point at 10,000 units. Likewise, for the plastic process down here, we calculate the break-even point. The sales price 10x is equal to 170,000 is the variable cost, the fixed cost, plus 2 times the number of units, which is the variable cost. And you can see that the break-even point is 21,250, much higher under the plastic process, just because this fixed cost is so high. Well, that's interesting, but let's say that we have a third option. Let's assume that we could actually buy instead of make these units at $8 per unit. We could purchase them off the shelf somewhere. So now what we have is three comparisons: metal versus plastic, metal versus buy, and plastic versus buy. So at what point does it make sense to switch from a metal process to a plastic, or a buy to a metal process? So what we do is we set those costs equal. Again, the fixed cost for the metal process, the variable cost for the metal process, equal to the total cost then for the plastic process as before, and we solve for 40,000 units. Okay, that's the point where it makes sense to switch from metal to plastic. If we do the same thing for metal versus buy, we've got, again, the total cost for the metal function process, okay, fixed cost, variable cost again, is equal to 8 times X, where 8 is the price we can purchase off the shelf, this item. So at this point, when we solve for this, we get 16,666. The third possibility down here is to calculate the plastic versus buy. At what point are those two cost functions the same? So we've got 170,000 plus 2x, which is the plastic process again, equal to 8x. And down here you can see barely that it's 28,333. Well, let's go ahead and plot all three of these cost functions in the next chart. Okay, on the x-axis here, we've got the number of units. We've got the costs over here on the y-axis. First, the buy. That's the steepest function here, which is 8x plotted. Then we got the metal function here, crossing the axis at 50,000, which is the fixed cost, going out there. And then the plastic. This isn't drawn to scale, by the way, but I think it's good enough to give you an idea of what's happening here. The plastic process crosses the axis at 170 and is the flattest of the three. So we want to minimize cost, right? So assuming that we buy, assuming that our demand is less than the 16,666, it's cheaper if we go ahead and buy down here. But once we cross that 16,666, the point here, it's better for us to go ahead and use the metal process, because that's the cheaper of the three functions now. And once we hit that 40,000 mark, that's where the costs of the metal process and the plastic process are the same. It's at that point that we should then switch to the plastic process. Now notice that the intersection point here that we calculated before of 28,333, that was where the plastic and the bi crossed. That really doesn't come into play here, because that intersection is higher than in the metal process. So we can ignore it. So the conclusion then is anywhere between 0 and 1666, we're going to go ahead and buy. From 1666 to 40,000, we're going to hit with the metal process with those parts. And anything above 40,000, it would pay off to go with the plastic process.